6.1. So what will be the unit digit of the squares of the following numbers? So what did I told you that how we can find the units digit, or what will be the unit digit of the given squares? How we can find the unit digit? So simple method of doing this by getting the unit digit. Unit digit is tell about the last digit of any square number. The last digit of any square number. Yes. For example, exercise 6.1, question number 1, unit digit. You simply have to multiply the last digit with the same number to make a square of that number. So simply we can find. Okay. Okay, so the question says, the first question says, what will be the unit digit of the squares of the following numbers? I will do the first part, then I will do the another two part, the rest of will be done by you. Okay, this is the first part, question number 181. I have to find the unit digit of this number. So basically this is a square, so this is the unit, this is the unit. We know that if a number has its units place digit as a, for example, this is a unit place. If I just start with a place value, this is 1 status as unit digit. Okay, and then its square will end with the unit digit of the multiplication a into a. You have to write this reason. We know that, and you have to use this reason in each question. You don't have to try to do the short steps. Okay, so the reason is most important in this exercise. We know that if a number has its units place a, units place digit, for example, the a is here is 1. Okay, units place digit as a, then its square will end with the unit digit of the multiplication, like a into a, multiplication between the same number. Okay, this is how we can get the I told you in the last class that how we can get the square of this one. Simply multiply 1 with the 1 same number. 1 square is equal to 1. Understood?
Yes, ma'am.
Any question?
No, ma'am.
So simply we're done with the reason. Now I will do how we can get this. Simply you just have to do.
Ma'am, that's the reason for all the questions?
Yes, this is the reason. And you just have to change the number. Last number will be changed. So since you can say that, since the given number, has its units place digit. What is the unit place digit of 81?
8 square.
1. Unit place is 1, Sukena.
Oh yeah, sorry, ma'am.
Its square will end with the unit digit of the multiplication.
Okay, ma'am.
Understood?
Yes, ma'am.
So it will look like 1 is the unit, is multiplying its same digit, and then we are getting the answer 1. Understood?
Yes, ma'am.
This is how you can get the unit digit of any number. Firstly, you have to understand each and everything. I will give time to you to write this. Okay, understood? Any questions, Sukena?
No, ma'am.
So, how you can find the unit digit of any number? You just have to pick the last digit. Last digit is unit. Because the given number has its unit place digit as 1. And its square will end with the unit digit of the multiplication. We just have to multiply the unit digit with the same number of multiplication number. Got it?
Yes.
Pick any other question that I will do for you.
V1.
Which one?
Sixth one, ma'am.
Sixth one says,
I know how to do all the questions now, so I think that's enough.
enough? One will be good. So you can do all of them. Like 1 to 10, 2 to 10. 9 questions will be there. You just have to use, if the question came in exam, you have to write the reason starts from here. Okay? Starts from, you have to write the whole reason. But if you have to write each question on your notes, na? When you are trying to write the first question, you have to give this reason from this to this. You just have to write this reason for once, only for once. Then when you are going to start answering the question like part by part, then you have to start this for each part. For example, if I tell you, then for the question number 2, the number is 272. I will not going to write this green statement again. I am just going to start with the red statement. Since the given number has this unit place digit as 2, its square will end with the unit digit of the multiplication. 2 into 2, 4. Understood? Any question?
Yes.
On the copy, you don't have to write this green statement again and again. You just have to write it like it for once at the start of your page, and you have to write the statement red for each number, for each question, and the unit digit should be different for each question. Got it? Understood?
Yes, ma'am.
Okay, can I move to the question number 2?
Yeah, ma'am.
What they are asking in the question number 2?
Ma'am, I did not write that one.
I just tell you, we will write everything at the last.
Okay. Question number 2.
Yes, question number 2. You just have to do the practice with me, okay? You don't have to open your neat register. You have your rough register for practice, is it?
Yeah, ma'am.
You have to open that register.
Yeah, ma'am, I'm using that one.
Okay, yes. Because when I will share the pictures and you have to write the notes, you have to use your that neat register for making proper notes. And for the practice, you have to use your rough register. Can I move to the question number 2?
Yes, ma'am.
Question number 2. The following numbers are obviously not perfect squares. Give reasons. Perfect squares mean we have to find the number. When we make a square, it will give us the correct answer. We have to find that number. Okay, the square of the numbers may end with, you know that the square of any number only ends with 0, 1, 5, 6 or 9. Also, a perfect square has an even number of zeros at the end of it. If there is any 0 at the end of a even number, that is also a perfect square. Okay?
Yes.
So first one is 1057. First you have to remember this list. In question number 2, if you have to find the number is a perfect square or not, then you have to remember these number. If these number are present in the last, these are the perfect square. The square of numbers may end with any any one of the digits like 0, 1, 5, 6 or 9. If these digits are ending with a number, that is a complete scare. Okay, understood?
Yes, ma'am.
Or also, and we also have the also perfect scare.
Okay, ma'am.
Perfect scare has even number
Okay, ma'am.
of zeros at the end of it.
Okay, ma'am.
So you have to remember this whole paragraph for the question number 2. Okay, and you have to write this whole paragraph after the question number 2. You don't have to repeat for each part. You just have to write it like for once, and you have to remember this. Okay.
Okay.
Okay, let's do the question number 2, part 1. The 1057 has its unit place digit as 7. Okay, and 7 sevens are 49. So do you think that 1057 is a complete scare, is a perfect scare or not? By looking at this list and this thing, can you tell me that the first one is a perfect scare or not?
It's a perfect.
How you can say that it's a perfect?
No, ma'am, it's not.
It's not. Why? Because its unit place digit as a 7. If its unit place digit is 0, 1, 5, 6, then it will be. Okay.
Okay.
So, this question number 2, you have to write like this. You have to write like this. 1057 has its unit place digit as 7. So you have to write the reason like this. Therefore, it cannot be a perfect scare. How we find that? Can you tell me how we found that it is not a perfect scare?
Because it does not belong to any number such as 1, 0,
Yes.
5, 9.
Done. Okay. Okay, Sukhana, what do you think about the next number? 23,453. 3 is a
Yes.
unit, its unit place is, what is the unit place of this number?
3.
3. Therefore, it can be a perfect or it cannot.
Cannot.
Good. And what do you think about the third one?
No.
Very good. And what do you think about the fourth one?
No.
Fifth one?
No.
Why? Because 64,000 has 3 zeros at the end of it. However, since a perfect scare cannot end with the odd number of zeros, it is not a perfect scare. If there are 2 zeros, even number of zeros, if they are 2, if they are 4, if they are 6, if they are 8, what they ask about in this, they ask about the number of zeros should be like odd. If there are even number of zeros, we cannot accept that as a perfect scare. So Kenna, did you understood this thing? That the number of zeros are even. Even means 0 should be like a counting of even number. 2, 4, 6, 8. And there are 3 zeros. So 3 is a odd number. This is cannot be a perfect scale. What do you think about the sixth one?
No.
Very good. What do you think about the seventh one?
No.
Eighth?
No.
Okay, all of this, since perfect scale cannot be end with a odd number of zeros, so all of are not a perfect scares. Understood?
Yes.
I have done with the first part and I let you know I explain it to you all of the part. I hope you can complete, and you have to just write this statement for once and you have to remember this. then you have to attempt all of the question by this method. You have to write this number like this, and the digit is placed as, and then you have to tell it cannot be all of them or cannot be a perfect square. Understood?
Okay, ma'am.
Any question?
No, ma'am.
I hope you will and still remember when you're trying to do the practice. You don't have to say me that, ma'am, when I am with you, when we are doing in the class, I understood everything, but when I'm alone, I try to do it by myself. I did not understood. Okay?
Okay.
Okay. So the question number 3. The squares of which of the following would be odd numbers?
The squares 1,
For
3.
example, we have to pick which of the following be a square of an odd number. For example, if there is any odd number, we will make a square and it gives us the answers. So the square of an odd number is odd. For example, if we choose an odd number, the answer will be the odd square. If we choose an even, the square of even number is even. So 431 and 770 779. You can see that 31 is an odd number, 79 is an odd number, 26 is an even number, and 4 is an even number by looking their last numbers. Understood?
Yes, ma'am.
So the here 431 and 7779 are odd numbers, and the square of 431 and 7799 will be an odd number. So let me write here the question number 3. You have to write this reason first. Okay? They didn't ask about you have to choose the even. You don't have to tell the even. You just have to tell me the odd numbers. Which of the following are the odd numbers? Before starting this question, you have to write this reason first. Every question in this exercise must require a reason. The square of an odd number is odd and the square of an even number is even. And let's do the answer. Here starts the solution. 431 and 7779 are odd numbers. What is the reason? Thus, the square, because the square of 431 and 7779 will be an odd number. Will be an odd number. Understood?
Yes, ma'am.
Any question?
No, ma'am.
If you have, you can ask.
No, ma'am.
Is it easy?
Yes, ma'am.
Okay. So we have done with the question number 3. Can I start the question number 4 now?
Yes, ma'am.
Observe the following pattern. You have to do this on your textbook. Observe the following pattern and find the missing digits. As I told you, 11 squares is 121. What if I put 0 between 11, 101? You have to make a square of that. Square. How you can get the square of any number, Sukena? How we can get a square of any number?
Multiplying them both.
Multiplying the same number with each other. Now you have to give me the proper multiplication. The first part is done, second is done, third is done, and we have to follow the pattern. Look here. If the 0 increases, the 0 between 1, 2 and 2, 1 is also increases. If the 0 between double 1 increases, then the 0 between 1, 2 and 2, 1 is also increases. Double on the both side. So look here. If there are 4 zeros, then in this blank there will be 4 zeros before 2 and 4 zeros after 2. And same thing, 6 zeros before 2, 6 zeros after. This is how you can do this pattern. Understood?
Yes, ma'am.
Yes. Done. And complete this. 1, 1, 2, 3, 4. For this second 1, 2, 3, 4. There is a 4 and then 1, 2, 3, 4, 5, 6 zeros.
Okay.
And again, question number 5 is like, observe the following pattern and supply the missing numbers. You have to give the missing numbers between them.
Yeah, ma'am.
Done? What do you think about the question number 5? Observe the following pattern and supply the missing number. Now the pattern is changed. For the 1, 1 square, this is 1, 2, 1. For 1, 0, 1 square, this is 1, 0, 2, 0, 1. For 1, 0, 1, 0, 1 square, this is 1, 0, 2, 0, 3, 0, 2, 0, 1. Understood? Now we have to find the square for 10, 10, 10, 1. In question number 5. Can you find the square of the fourth number? 1, 0, 2, 0, 3, 0. And then again with the 4, 0, 3, 0, 2, 0. They're just counting the numbers between. Okay. So here are the total numbers are. I will do it here. Question number 5. So it look like 1, 0, 1, 0, 1, 0, 1 square. We have to find the missing number. So it will look like 1. You just have to remember like this. 1, 2, 3, 4. Then again with the back counting. 3, 2, 1. Now you just have to place the zeros between the empty places. 0, 0, 0, 0, 0.
How do you know that there are only 4 digits in there?
Because here is counting. Look at the counting. 1, 2, 3, 4. 1, 2, 3, 4. 3, 2, 1. That's why. And there is a 0 between every one. So the pattern for the square is also the same. Even you can by multiply these two, you will get the same answer. Can you just in a minute give me the answer by multiplying these two? Like you have to multiply 1, 0, 1, 0, 1, 0. 10, 10, 10, 10, 10 with each other. You will get the exactly same answer. 1, 0, 2, 0, 3, 0, 4, 0, 3, 0, 2, 0 and then 1. Are you doing?
Yeah.
Okay, complete it and give me the answer. After multiplying these two numbers, we are getting the exactly same answer. So, question number 5. Can you do? So, next number we have the answer, but we don't have the number from which we get this answer. So, we have to find the number by looking at above. Above we have the zeros. Is it? So, we just have to change the pattern. Like for the 10, 10, 10, we above 10 we have 3 times. Now we have to put 10, 10, 10, 10 4 times. And then 1. You just have to write 10, 10, 10 and then 101. And you will get the exactly same answer. Okay?
Okay, ma'am.
Understood?
Yes.
Any question?
No, ma'am.
Question number 6. Using the given pattern, find the missing numbers. So from the given pattern, it can be observed that 1 square plus 2 square plus 2 square is equal to 3 square. We just have to fill the blanks for the missing numbers. So look here, 4 square plus 5 square. Which number will be added to give a 21 square?
21 square.
No, the 21 square. First you have to find the answer. What is the 21 square? What is 21 square? By multiplying 21, 21 multiplied by 21, we get the answer.
No, ma'am, the missing digit will be 20.
Okay, 20. How you find that 20?
Because the first two numbers are multiplied. That's the third digit.
Very
and
good.
The third digit is like adding plus 1 to it gives us 3 squares.
Very good. This is the same thing I told you, that by multiplying the first two number we will get the answer. We will get the product. So here is the answer is 20. 4 5s are 20. And which digit is multiplied with the 30 to get, which digit is multiplied with the 5 to get answer 30?
6.
Very good. And what do you think about the last number?
6 1 6 6 6 12 16 17 6 4 26 42.
42. And what will be the answer?
43.
Very good. Okay, 7 number. Question number 7. Without adding, find the sum. We don't have to add. We just have to tell the answer without adding. How? Like 1, 3 plus 5 plus 7 plus 9. We have to find the sum of the first 5 odd natural numbers. How we can do that? How many numbers are there?
1 2 3 4 5.
So, this is a simple thing you can do. This is
25.
How you get the 25? They ask, you don't have to add them without adding.
Yeah, I multiplied 5 to 5.
Very good. So question number, this is a question number 7. Let me explain. Question number 7. In this, you have to count all the odds digits present and you have to make a scale of that number. For example, let's count. First digit are 1, 2, 3, 4 and 5. 5 digits. I will make 5 scale. 5 5s are 25 and without adding I get the sum of this answer. Understood?
Yeah, ma'am.
Okay, how many digits we have in the third, in the second?
100.
10, we have the 10, then we have to make scale.
The answer is 100.
Very good. Then answer is 100. Vaikka, what do you think about the third one?
1 minute. 144.
Yes, 12 and then scale is equal to 144. Very good. Understood?
Yes, ma'am.
Okay, now move to the question number 8. Express 49 as the sum of 7 odd numbers. Express 49 as the sum of 7 odd numbers.
It's going to be 1 plus 3 plus 5 plus 7 plus 9 plus 11. Plus 13.
Yes, we have to add first 7 odd numbers, then we will get the answer. So the question number 8, first part. First 49 is the sum of first 7, like 1, 3, 5, 7, 9, 11 and 13. And how we can get 121? First 11 odd natural numbers.
1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21.
17, 13 plus 15 plus 17 plus 19 plus 21, we get the answer 121. Very good. Okay, now the question number 9. How many numbers lie between the squares of the following numbers? How many numbers?
1 no, not 0.
So we know that there will be two n numbers in between the square of numbers n and n plus 1. So between 12 square and 30 square there will be,
Numbers between.
how we can find the numbers?
I don't know that.
We know that because if we have to find a number between that, we know that we just have to find, this is a question number 9. This is how we have to do. We know that there will be 2 n numbers. There will be 2 n numbers in between the squares of the numbers n and n plus 1. So here, what is n here? Between 12 and 13. First digit is the n here. Every first digit is n here. So I can write n is equal to 12. Thus I wrote 2n. So the first part between 12 square and 13 square, there will be 2 multiplied by 12 is equal to 24 numbers. We have to find the numbers, how many numbers are between them. Simply. Understood?
What about 13, ma'am?
We don't have to use, we have to start from, because n is the start-up number. We have to find that number that is between 12 and 13. And there will be 2 n numbers. So n is the 12th one. Same as it is for the next one, 25 is the n1. And the for next one, 99 is the n1. So can you do the part second and third and give me the answer?
25.
You just have to 2n. You can just say 2 multiplied by 25. And then 2n is equal to 2 multiplied by 99.
No, we have to find like there is between 6, 8, 10 like that.
We have to, yes, there are 24 numbers. I have to find that 24 numbers.
Okay.
Yes. So how many 24 numbers are there?
Like, what are the numbers?
Yes. They don't ask about name of the number. They ask about how many numbers. Like we have to give the quantity.
Okay. Numbers.
For the 25, that is 50, and for the 99,
2 9s are 81. 8. No, 2 9s are 18. 198.
very good, correct answer, 198. Any question?
No, ma'am.
Now we can start. Now we have to start the exercise 6.3. Before starting 6.3, this is a finding the square of a number. How you can find the square of the number. For example, this is 23. You have to break 23. 20 plus 3. Then you have to make, remember this is the thing we have done in the previous exercise. Like in which chapter?
What is it again?
The square.
Can you do? Algebraic expression.
Yes, very good. So 20 plus 3. 20 here is A, 3 is B, A square plus B square plus 2AB. You just have to open. You just have to open the first part. For example, if I open 20 plus 3 and then 20 multiplied by 20, you can do this and you can do the second part as well, the formula. And we will get the exactly same answer. This is how you can find the square. You don't have to do the direct step 20 multiplied by 23. But you should know that this is the answer. For checking, you have to do this like opening or completing square formula. Okay?
Okay, ma'am.
Okay, the other patterns in squares are like, look here, 6.4.1. Consider the following pattern. 25 squares is equal to 625. 2 3 hundreds plus 25. So this is a pattern. They are multiplying 2 with a 3. 2 3s are 6. 600 is going to multiply plus with 25. That will give us 625. This is a place of hundreds. Okay. So it will look like you have to pick the first number. Okay. The first number, you have to get the answer of the first digit or two digit. Then you have to multiply that with the 100 and add with the last digit. I hope you understood. Like this.
Yeah, ma'am.
Like this is a 625. I will use this as a 6. I will find that number that is give me the answer exactly 6. So that is a 2 3s are 6. 2 3s are 6 and I have to multiply this with 100 according to looking at my unit place. Then I have to add with the 25. Now 2 3s are 6 is multiplying with 100 and plus with 25. It will give me 625. Understood?
Okay.
Yes. This is how you have to do this. This is known as, so this is the MCQs in your past yearly exam, Pythagorean triplets. Consider the following. 3 square plus 4 square. 3 square 9, 4 square 16. We get 25. And 25 is also the square of 5. The collection of number 3, 4 and 5 is known as the Pythagorean triplet. 6, 8, 10 is also the Pythagorean triplet. Simply, if we add 6 plus 8, what we get? 14. 14. Oh, we just have to look like this. We can just switch the numbers. And if the number, like look here, 6 square is equal to 36. 36 plus 64, we get the answer 100. And 100 is the square of 10. By adding the sum of square of two numbers, and their answer is the square, complete square of one number, that is known as Pythagorean triplet. You have to write important on above Pythagorean triplet.
Okay, ma'am. I got a question.
Okay. Exercise 6.2, the question number is a Pythagorean triplet. This is an important question. You have to mark important. You have to add the questions and you have to do the practice of these examples and the question from this exercise. So basically in this we just have to find if this is a 6. We have to find the Pythagorean triplet of the given number and the 6.
Okay.
And by using the formula of m square plus 1, m square minus 1 and 2m, we have to find the another integers of 6. Okay, so simply I will solve this with the, if I didn't get this, then I have to change my format. So if we take as m square plus 1 is equal to 6, got it? Then I'm doing for the positive first. Then m square here is equal to 6 minus 1. Then I will get the answer 5. And the value of m will not be an integer. This is not an integer. Okay. I will write here not an integer. This is a reason. Now I will do for the negative. I have done with the positive. Now I have to do for the negative. M square minus 1 is equal to 6. And then again m square is equal to, it will look like, it will become minus 1 minus 6. And then m square is equal to 7. Okay. So it is again, m is not an integer. Not an integer. Understood?
Yes, ma'am.
And now the way I have to do this for m. Okay. Like 2m is equal to 6. And m is equal to 6 by 2. Answer is 3. I have the answer 3. Is it? I get the answer 3.
Yeah, ma'am.
But I didn't get the answer like 5 and 6. That is not the integers. So the Pythagorean triplets, we have to write the Pythagorean triplets like this. Therefore, Pythagorean
Triplet.
triplets for 6.
Okay.
You can say that 2 multiplied by 3, 3 square, because I just get the answer here. Look, I get the answer m is equal to 3 na, m is equal to 3 by solving m is equal to 3. How, where I get the m is equal to 3? From where I get this value? From here. From here. I just put the value of m in each of the format. In which format? These.
Each of the four.
Like 2m, 2m, m square minus 1, m square. Here I will get my triplet of 6. Now I will put the value 2 multiplied by 3 and then 3 square minus 1 and then 3 square plus 1. 2 3s are 6. Now 3 square is equal to
3 square is
9 minus 1, 8, and then 3 square 9 plus 1 gives 10. So this is how I get the answer, because by looking at these number, here I get 7, here I get 6. I don't want to have these answers like m, 5, 3 and 6. I have to get the proper Pythagorean triplet. I just use the value of m, I put the value of m and I get the answers. The answers are 6, 8 and 10. 6, 8 and 10. Understood?
Yes.
Okay. So can you do the part number 2 for me?
Yeah, ma'am.
Simply you have to do with the 2m and you will get the value of m. You have to put the value of m in m square minus 1, m square plus 1. Then you will get the exactly triplet. Okay?
M square 14 squared plus 14 into 14. 49. 4 are 8. 1s are 4. 4, 5, 6, 7, 8. 4 4s are 16. 14 into m square, right? So 14 into 14. 4 4s are 16. 4 1s are 4 plus 1 5. M square